Hello everyone. So I'm going to discuss this question today. This question is related to the topic decision tree. Okay. The question actually I'm going to discuss two questions. Question number 7 and 8. The question is from the assignment 6 of this particular course, Introduction to Machine Learning by NPTEL. Okay. So let's see what is the question about. So we need to consider this following data set. We need to build a decision tree. Okay, here. So decision tree for classification we can use, and there is a particular algorithm to construct a decision tree that is called ID3 algorithm. Now this algorithm, it uses entropy, okay, as well as information gain to calculate different roots or different nodes of this particular decision tree. Okay, now this data set is given where age, then vaccination, tumor size, tumor site, these are the feature values. Okay, these are the feature values, whereas based on these feature values we can conclude something. We can conclude that whether that particular tumor is malignant tumor or not malignant tumor. Okay, so there are two classes of this target feature here. Target feature, which is also called class level. Okay, class level. So it is having 0 classes and 1 class. Okay, so we'll consider these as the positive class, and all the 0 class labels will consider as negative classes. Okay, so basically this decision tree will be able to decide upon these two classes based on the different feature values whether that particular tumor is a negative class of malignant or positive class of malignant. Okay, the question in question number 7 is what is the initial entropy of malignant. Now to calculate entropy we have this equation. Okay, in ID3, this particular ID3 algorithm, it is having how many negative classes? It is having 7 negative class. 1 2 3 4 5 6 7. There are 7 negative data points, and 1 2 3 4 5. There are 5 positive data points, right? Like data points whose class labels are positive and data points whose class labels are negative. Okay, now to calculate this entropy we have this formula. Entropy entropy of this entire, if we consider the data set as S, okay, then entropy of this entire data set or entropy of the data set which decides whether a tumor is malignant tumor or non-malignant tumor. Okay, so for that the entropy that we can calculate, it has the formula minus P. Okay, P stands for positive upon P plus N. N will be for negative data points. Okay, then log of P upon P plus N. Now here what is the base of this particular logarithm? Because I am having only 2 classes. Okay, so that's why the base of this logarithm will be 2. If my data set is having 3 number of classes, the base of the log will be 3. Okay, likewise minus n by P plus N. Again log of base 2 n by P plus N. So this is the formula for entropy to calculate the entropy of this data set. Okay, so this formula is fixed. We can remember this formula. Now we will see here P will be positive, right? P is what is the count of this P? 5, and the count of N will be 7. Okay. So that's why I have written 5 positive and 7 negative, just to check how many p values are there, what is the will be the count of p, and how many n values will be there. So that is my p and n. Okay, so minus how many p, 5, right? Then p plus n, 5 plus 7, that is 12, right? 7 log base 2 here, 5 plus 7 minus n count is 7, then 5 plus 7 log base 2, 7 by 5 plus 7, okay, which is 5 minus 5, 12 log 2, 5 by 12 minus 7, 12 log base 2, 7 by 12. Okay, these values are what? After doing the calculation, actually this values 5 by 12, it comes as 0.417, okay, multiplied by what? Log base 2 of 0.417. This will be initially minus only, okay, then minus the 7 by 12 value comes as 0.583, then log base 2, 0.583, okay. Final value will be log base 2 of this 0.417. Whatever value we get, that value is a negative value, and negative, that's why I cancel out, and final value is 0. Final value only I am giving you 0.9798, okay. So out of all the options, the option number 2 is closer to my values, right? 0.9798, okay, that is the entropy, that is the answer, okay. Then what is the second question? The second question is, for the same data set, what is the information gain of vaccination? Okay, so in this data set you can see that vaccination is also having some attribute values or feature values. The feature values are only two types only, 1, 1, 1 and zeros, okay. So that is the we'll now summarize about vaccination here. Vaccination is having how many p values, how many n values, and what will be the entropy, okay. So here means vaccination can have any kind of feature value. What are the available feature value in the data set? 1 and 0, okay. So let me consider one feature value. Now this one feature value will have some positive count and negative count, means for a particular feature value, suppose 1, this first data point or first row of the data is having positive classes or negative class, okay. Then the second data point 1, it is having what? It is also having negative class, on class level is 0. Then the fourth data point is 1, it is also having negative class. Next is again it is having negative class, and then row number 5, it is also having negative class, okay. So there is possibility that for some of the feature values 1, there might be a positive class also in some other data set, okay. But for this particular data set, this one feature value, it is having what we need? I need the positive count and the negative count. Now for this particular data set, this feature value 1 is having all values negative only, okay. And how many such values exist? 1, 2, 3, 4, 5. 5 negative value, and how many positive value for 1? 0, correct. So here p I will be writing as 0, whereas this negative classes data points for one feature value is what? 5, okay. Similarly, I will be checking for zeros. Okay, the other feature value that is available in this vaccination feature or attribute is 0, right? Now this 0 is having what? Suppose this 0, let me change the color, I think that will be better. Yes, so here now this one is 0, right? 0 is having this one negative the count, then the two negative count, right? After that this is 1 0, it is having positive count, right? So it is having positive count. Then next 0 positive count is 2, again next 0 it is also having positive value, right? Positive count is 3, next 0 positive count is 4, next 0 for this 0 also class label is 1, so it is positive count is 5. Whereas for this 0 the count of negative is 1, then for the next 0 it is 2, right? So how many for this 0, what will be the count of n? That is 2, n negative 2, and the count of p positive classes will be 5. Okay, that's what we are going to write here. Positive classes, this is 5, whereas this is 2. Okay, now we'll again calculate entropy. Now for calculating entropy, again the formula we know what we need to write here. What is the formula? For just a few minutes back we have calculated, right? Minus p by p plus n log base 2, because it is class 2, p by p plus n, minus n by p plus n log base 2 n by p plus n, p plus n. Okay, this was the formula for entropy, right? So similarly I am having p value here, n value here, I can apply this formula. So after applying, actually when this is 0, right? So the values will be what? Minus 0 divided by p plus n is what? 5. So whatever we will multiply here, okay, ultimately entire value will be 0, right? Minus it is what? N is 5, then 5, okay, log of 5 by 5 again. Now log of this is ultimately 1, log of 1 is again this value is 0. Okay, so finally 0 minus 0, it is 0. Then the next values here, minus 5, it will be 7, log base 2, 5 by 7, minus 2 by 7, log base 2, 2 by 7. Okay, these values are equal to, after the calculation, this entire value is 0.5163 plus this entire value. This log will give me a negative value, that's why this minus and that minus will be cancelling out, and final value is 0.3467, which is equal to nothing but 0.8630. Okay, so this for the second row the value is 886.8630. Okay, now if we try to plot it in the form of a decision tree, okay, this is the vaccination attribute. Okay, under this attribute I am having attribute value 1. For 1 I am having few positive count. How many positive count? 0 positive count and 5 negative count. Then under this vaccination attribute or feature I am having attribute value 0, and it is having 5 positive count and 2 negative count, right? Now the final call to calculate this information gain. Okay, again what is the formula for information gain? That only let me elaborate here. Information gain for vaccination, okay, that is nothing but entropy of the total data set. Okay, entropy of the total data set minus what we have total number of your how many here you see I am having two feature values, right? This is one feature value and this is another feature value. So for the first feature value, what is the total count of this feature value? Okay, that count is what? That is 5, right? 5, and upon I'll be writing this entire count upon total how many such values are there. Total 12 such values are there, right? 1 2 3 4 5 5 for this feature, then 6 7 8 9 10 11 12 total whatever many rows are there in this data set, that will be my final total value, right? So that is 5 plus 7, which is 12 only. Then again I'll be writing here now this value will be the entropy just now that I calculated for this one value. Okay, that entropy is nothing but 0. Okay, I need to multiply this 5 upon this total number of such data point multiplied by the entropy of this 5 value. Okay, how many for one feature value count is there, then minus for the second feature value 5 plus 2, so total it will be 7 divided by again 5 plus 7 multiplied by the entropy for this particular row. What is the entropy? Just now we calculated, that is 0.8630. okay, which is equal to entropy of the entire data set that we calculated for the previous question, it was 0.9798. so 0.9798 minus this is 0 minus this entire value after calculation, this value is 0.5034. so which is equal to final value is 0.4764. okay, this is what I got, and this particular value is closest to the option A, right? 4763. My value is 4764. okay, so that is about that is the answer for this question. If there is any doubt regarding this question, then you can post in the comment. Thank you.